Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in today's video lecture we are going to study the types of IC regulators. IC regulators. What is the use of IC regulator? The IC regulators are used to eliminate the drawback of the previous types of regulators. The previous types of regulators are transistor regulators and a Zener regulator. What is the drawback of Zener regulator? In case of Zener regulator, the load current is very low. And this drawback is removed by using the next type of regulator, that is known as transistor regulator. In transistor regulator, the load current is increases. But in this case, the series pass transistor has to dissipate more amount of heat, because the maximum load current, the all load current passes through that series pass transistor, and as the load current is very high, it is in range of some ampere, 1.5 ampere is a load current that will be available in case of transistor regulators, and to dissipate, to handle this large current, that is up to 1.5 ampere, the heat sinks are required, because due to that large current, the power dissipation is very high and that power is dissipated in form of heat. And to dissipate that power, we require the heat sinks, and due to the heat sinks, the size, cost and weight of the instrument increases. So this drawback of heat sinks is removed by using the next type of regulator, that is known as IC regulator. Friends, in the decades of 90s, the multi-pin IC regulators are used. That means that regulator IC has more number of pins, and due to the more number of pins, the more number of external components are required. For example, IC LM723 and IC LM300 series. This IC has more number of pins, and due to the more number of pins, the more number of external components are required, and due to that more number of external components, obviously the cost of that power supply increases. And this drawback is also removed by using the next type of regulator, that is known as a 3-pin regulator. Friends, in case of 3-pin regulator, it has only 3 pins. One pin is used for the input, that means the input signal which has to be regulated is applied to the one pin. The another pin, that is the second pin, is a common, or it is also known as the adjustable, because there are two types of IC regulators, fixed regulator and variable regulator. In case of fixed regulator, the second pin is known as a common pin, while in case of adjustable regulator, that pin is known as adjustable pin. And the next pin, that is the output terminal. That means one pin is used as an input terminal, one pin is common, and the another pin delivers the regulated DC potential. So as there are only the 3 pins, the external component used are less in number. So obviously the cost of that power supply decreases. These 3-pin regulators are widely used because they can conduct a load current up to 3 ampere. 3 ampere is a sufficient current in case of our electronic appliances. So this regulator, that IC regulators, can handle a current up to 3 ampere. And they are available in fixed and adjustable modes. Fixed are of 2 types, that is of positive regulators and negative regulators, and adjustable, that varies the output potential, that is going to adjust the output potential from its minimum to maximum value. And because of these advantages, main advantage, it can gives a load current up to 3 ampere. The output current is in range of 3 ampere, and because of this advantage, that 3-pin IC regulators are widely used in electronic power supply. Friends, now the block diagram of that 3-pin IC regulator is going to display on your screen. The first block is known as series pass transistor. The first block, this is our first block. This first block is known as series pass transistor. The second block is known as current limiting and thermal shutdown circuit. Thermal shutdown and current limiting circuit, that is the second block. The third block is the error amplifier, that is also known as comparator. It is the error amplifier, and that is also known as a comparator. And the fourth block, actually it is a potential divider network formed by the 2 resistors R1 and R2 of fixed resistance value. And a load resistor is there, across that load resistor the output potential will develop. So this is the block diagram of 3-pin IC regulator. So friends, V input, that is the input voltage which is to be regulated, is applied to that input terminus, and output potential, that is a fixed or it is a constant DC potential, is developed across the output terminus. So friend, this is the block diagram of pin IC regulator. Now we are going to study the function of each block. First block, 3-pin regulator consists of first series pass transistor, second current limiting and thermal shutdown circuit, third error amplifier or it is known as a comparator, the fourth, that is a potential divider network formed by resistor R1 and R2. Now the function of first block. In this case, there is inbuilt reference potential. In that circuit diagram, V reference is marked. The symbol of battery is there, and this V reference is known as the inbuilt potential, inbuilt reference potential, and that inbuilt reference potential is connected to the non-inverting input terminal of op-amp. This is actually operational amplifier. This is a symbol of operational amplifier, and in this case, operational amplifier is work as a comparator. In case of comparator, the input signal will be going to compare with some reference, and in this case, the reference potential, that is inbuilt reference potential, is connected to the non-inverting terminal, while the output voltage of that IC, output voltage of power supply, is feedback, and that feedback potential is connected to the inverting terminal through a potential divider network that is formed by two fixed value resistors R1 and R2. So the inbuilt reference potential, that is fixed potential, is connected to the non-inverting terminal, and the input potential, that is output voltage, is feedback and is applied to inverting terminal of comparator, or that is the error amplifier. Friends, the next block is our power supply, is our series pass transistor. The output potential, if we are going to compare that, if output potential is more than the required value. For example, if output voltage is standard voltage is 12 volt. Sorry, and unfortunately this output potential increases due to some accident or due to some causes, output voltage increases. That means when output voltage is more than the required value, then the input potential applied to the comparator is also increases. For example, if R1 and R2 are fixed resistors of same resistance value is used, the output potential is divided into two equal parts. That means the 12 volt is divided into 6 volt. The potential drop across R1 will be 6 volt and potential drop across R2 will be also 6 volt. And that 6 volt is now the input potential for the comparator. But due to some causes, that output voltage increases and it goes to 14 volt. That means now the input potential applied to that comparator goes to 7 volt. 7 and 7. 7 volt will develop across R1, 7 volt will develop across R2. That means in this case, for that error amplifier, for that comparator, the 1 volt more potential is applied to inverting terminals. That means inverting potential is now greater than the reference potential or more than the actual input potential. Actually ते 6 होतं, आता ते किती झालं? 7 झालं. Due to which the output of comparator decreases by 1 volt. Why it decreases by 1 volt? Because the input potential applied to the inverting terminal is increases by 1. The output of comparator, the output of error amplifier is decreases by 1 volt. Suppose it is in ideal conditions. मी आपण काय करतो ते ideal conditions मध्ये आहे असं imagine करतोय. Therefore, the output voltage of comparator decreases by 1 volt. And obviously, the base potential, the potential applied to the base of transistor is also decreases. And due to which, as the base potential of that series pass transistor decreases, the base current decreases, and hence the load current, that is IL, which is approximately equal to IE, or it is approximately equal to IC, that also decreases, because the IC is equal to beta times IB. As IB decreases, IC also decreases, and IC is nothing but IL. Therefore, the load current decreases, and due to which the output voltage also start to decreases and try to reach its standard value, that may be in our case we are considered as 12 volt. That is one case. Suppose output voltage decreases. If 12 volt is our standard potential and due to some causes the output voltage drops to 10 volt. So obviously the input applied to the error amplifier is decreases. In standard case it is 6 volt, now it goes to 5 volt. That means the input applied to the inverting terminal is decreases by 1 volt. The output of error amplifier or output of comparator increases by 1 volt. 1 volt ने ते वाढलं. As the output voltage of error amplifier increases by 1 volt, the biasing potential of series pass transistor also increases. That means the input current, that means IB of series pass transistor increases, and obviously the load current, that is IC or IL, also increases. That means as IL increases, the load voltage, which is already decreases, try to increase and goes to its standard output potential. In our case, we are considered as 12 volt. इथे 12 volt येईपर्यंत तुमचा लोड करंट काय होईल, वाढत जाईल. So this is the condition how this series pass transistor work. Now the function of काय गडबड झाली, PPT मिस झाली.